Hello. Good morning, everyone. So today,
Good morning.
once again, yes. So today, once again, we'll be extending our discussion related to nested subqueries. In the last few sessions, we have gone through the concept of nested subqueries, and we have seen set membership clauses in, not in. Also, we have seen the set comparison clauses some and all. So, in the same context, we are going to see one more example under set comparison today, and then we'll proceed with the next construct. So, which are the set comparison clauses? We have seen in the last session. Which are the set comparison clauses? Yes? Anybody? Set comparison clauses.
Some and all.
Some and all. Yes. So, we are having the sum clause and the all clause. So, we have seen these two clauses in the last session. So, let us try to write one more query with the help of set comparison clause. What we want is, we want to find the departments that have the highest average salary. What we want? We want to find out the departments that have the highest average salary. So how we are going to write this query? Just think on. Let us try to build the logic. What we want to find out the departments that have the highest average salary. So the important thing is, we need to find out first the average salary of each department. Average salary of each department. And then we need to come up with the construct so that we can have the department name having the highest average salary. Right? So we may split writing of this query in two parts. First of all, we will make use of group by clause to find out average salary of each department. Is that correct? So how to write this statement? We have written this statement earlier. How do we write this statement? Finding out average salary of each department. So whenever we say each department, we need to make use of group by clause. Correct? So how we can write this query? We may write this query like select average salary from instructor group by department name. So if we write this query, what we will get? We will get department name and the average salary of that department. Right? So we are partially done. What next has been asked for? We are asked to find out the department that have the highest average salary. So if we use this as the subquery, in this subquery, we'll be having the average salaries of all the departments. Right? So what we want is, we want to find out the department that is having the highest salary. So in outer query, what we can write is, we want to extract department name. Right? So we may write this query like select department name from instructor group by department name having average salary that is greater than or equal to all. So this outer query will find out every department, right? And this outer query will check whether the average salary of that department is greater than or equal to all the salaries those are present in the outcome of this inner query. If it is greater than or equal to, that means it is the highest average salary, and that is why that department can be extracted in the final output. So this is how we are going to write this query. Right? If we want to list out salary also along with the department, then we may include in the outer query this attribute salary as well. So please see carefully how we have built up the logic. As we want to find out the average salary for each department, we have written this subquery. Select average salary from instructor, group by department name. So this will provide me output with average salary of the department. In the outer query, we want to check whether that average salary is greater than or equal to all the values. Those are provided by this inner query. Right? And this is how we are making use of the construct greater than or fine. So let's proceed with the implementation of this query. So let's try to write the query. Here we have written the query like select department name from instructor, group by department name, having average salary greater than or equal to all. Select average salary from instructor, group by department name. Now please see here, we would like to compare the average salary, right? And that is why we need to make use of this having clause. And if we are using having clause, we should group our data. Unless we group the data, it is not possible to use having clause. And that is why in the outer query, we have made use of this group by clause. So we are grouping the data according to department name. And once the data is grouped, then for that group, whatever is the average salary, right, we can compare that average salary with the result of this inner query. So let us see first what is the result of this inner query. So we have written the statement select average salary from instructor, group by department name. So whenever we execute this query, what we are getting is the average salaries of each department. As we want to to compare the salaries, we are not extracting here department name in the inner query. Please remember, right? Because whenever we are comparing one value with another value. So this inner query must provide me a relation with a single column wherein we are having the values. So we are having only average salary in the inner query. We are not showing respective department name because that is not necessary here, right? So once we have got all those average salaries, each department, then what we are doing is we are comparing now the average salary of every department with all those values, right? And we are having here the comparison greater than or equal to. So once again, in this outer query, what we are having department name, and obviously as we are grouping here and we are having the condition on average salary, we are checking average salary of each department in the outer query. So in outer query, we'll be having the first average salary, say 80,000. So this 80,000 will be compared with all those salaries. Those are output of the inner query. So 80,000 gets compared. We are checking whether 80,000 is greater than or equal to all. Greater than or equal to all. So the evaluation would be false because 80,000 is less than 91,000. 80,000 is less than 85,000, right? So 80,000 is greater than or equal to all will be evaluated as false, and that respective department name will not be there in my final result, right? So only the department name for which the salary is greater than or equal to all those values will be there in my output. So whichever is the department for which the average salary is 91,000, that should be my result. Okay, so let us try to execute now this query and see whatever we are getting. So we are getting department name as physics. So physics department is having the average salary which is the highest. Okay, so physics department is having highest average salary. So if we want to verify that, let us try to list out here average salary as well so that we can understand. So let us try to list out name of the department and average salary. See here, physics department is having the highest salary. Okay, and that is what is expected in the result. So if we execute this query, it is providing us physics department for which the average salary is highest. Got it? Is there any doubt?
No,
Yes?
ma'am. No doubt.
It is possible to write the query in different ways, right? So this is one way by making use of nested subquery. It is possible to write the same query by making use of derived relations or by making use of with clause. We are going to cover those concepts in coming sessions, right? But please remember that one query can be written, or the data that we would like to extract, the query to extract the data that is desired, we may have different forms of queries. So this is one way of writing the query for finding out the department having highest salary. We are having several different ways to do the same thing. In the coming sessions, we are going to look at these constructs, how to make use of derived relations or how to make use of with clause to write such complex queries. Okay, so let me proceed now with the next form of subquery. And in this form of subquery, we are going to test whether the subquery is providing us the empty relation. So SQL includes a functionality for testing whether a subquery is having any tuples in its result or whether the subquery is providing a relation which is empty. Right? So it is possible for us to test whether the subquery result is empty or non-empty. To do this, we are having two clauses. So we are going to look at these clauses. So let us see the first clause, the exist clause. So this exist construct returns the value true if the argument subquery is non-empty. What does this mean? We are going to write the query and we are making use of this exist clause. So after this exist clause, we are supposed to write a subquery. Right? So subquery is nothing but a select statement. So this select statement is actually providing us this relation R. Right? So whatever is the relation that is provided by this subquery, if this relation is non-empty, meaning if there are any tuples present in this relation, then this exist clause will be evaluated as true. Okay, and if exist clause is evaluated as true, then the respective tuple in the outer query will be extracted in the final result. If this exist clause is evaluated as false, then the respective tuple in the outer query will not be included in the result. We are going to focus upon these concepts with examples, but please try to understand the concept first. So the exist construct returns the value true if the subquery is providing us a non-empty relation. If it provides the empty relation, then this will be evaluated as false. Right? Now, similar to exist, we are having another clause that is not exist. So this construct returns the value true if the argument subquery is empty. So it is exactly opposite to exist. So not exist, and then we are having the relation, and this relation is generated by my subquery. Right? So if this subquery is creating a relation R which is empty, then this not exist clause will be evaluated as true. Otherwise, it will be evaluated as false. Okay? So let us see the example so that we can understand this concept clearly. So we want to find out all courses taught in both fall 2009 semester and spring 2010 semester. Now, we have written this query in several ways. right? We have written this query in several different ways earlier. Find all courses taught in both the fall 2009 semester and in spring 2010 semester. So, how we have written this query earlier? Anybody? We have written this query earlier. So, which constructs we have used earlier? Yes, anybody? Set membership, which clause we used?
In and not in.
So, for this query, which clause to be used?
Interest.
In clause. So, if we go with set membership, then it is possible to write this query by making use of in clause. What is the alternative? The other way? Yes? The other way to write this query? Intersect, correct?
Intersect.
Yes. So, we may use intersect, correct? So, we have seen these two ways to write the same query to find out the courses. Those are taught in both of these semesters. In clause or intersect operation. Now, we are going to make use of one more construct now, and that is the exists. So, let us see how we can make use of this clause. So, see here how we have written the query. Select course ID from section as S. So, we are using here this tuple where this AND clause. So, we are ANDing this condition. So, and we are making use of now this exist clause. And this is my subquery. Right? So, what we are writing in this subquery? See what we are writing. Select start from section. Now, once again we are using the same relation, so we are renaming it. So, section as T, where semester is spring and year is 2010. And see here, and S dot course ID is equal to T dot course ID. So, see how this query gets. These three courses are being taught. Let us assume. So, course ID 1, 2, 3 are being taught in semester fall 2009. Okay. Now, how this query gets executed? So, in this outer query, we are having these three course IDs. So, for every course ID now, for every course ID that we are getting as the result of outer query, we are forming one relation as the output of this inner query. So, in this inner query, what we are trying to do? We are trying to find out all the attributes from section where semester equal to spring and year equal to 2010. And the course we are matching with the course ID from the outer query. So this will be evaluated now for course ID 1, the first ID in the result of outer query. So in this inner query result, we'll be having all the attributes from section such that course ID is equal to 1. So if this particular course ID 1 is being taught in spring 2010, then we'll be having here few tuples. If that course ID is taught in spring 2010, if it is not taught in spring 2010, then we'll be having this relation which is empty. So we will not have anything in this output of subquery. So if course ID 1 is taught in spring 2010, then we will have this relation that is non-empty. And if we do not have any tuple, so if course ID 1 is not taught in spring 2010, then the relation will be empty. So if we are getting the non-empty relation, then this particular course ID will be included in our final result. If we are getting this relation as empty, then that will not be included in our result. So let us assume that for course ID 1, right, we are having some tuples here. That means course ID 1 is being taught in spring 2010. So exist with non-empty relation will be evaluated in our result. Now, what happens next? It will consider the next tuple in the outer subqueries having course ID 2. So once again, for course ID 2, this inner query will be evaluated. So let us assume that whenever for course ID equal to 2, this query gets executed, we will get empty relation. So what we mean by empty relation? This means that in this result, we will not be having any tuple. Meaning this course ID 2 is not being taught in spring 2010. That is why this relation is empty. And if this is empty relation, then this exist clause will be evaluated as false because this is my empty relation. And if this is empty relation, exist clause will be evaluated as false, and that particular course ID will not be included in my result. So 2 will not be there. Okay. Now, if we are having one more course ID in the outer subquery result, then the same computation will be done for this course ID 3 as well. Now, let us assume that this course ID 3 is being taught, okay, in spring 2010. So this is non-empty. Inner query result is non-empty. So now my exist clause will be evaluated as true because the inner query result is non-empty. And if it is evaluated as true, then this course ID 3 will be included in my final result. Are you getting me?
Yes, ma'am.
Fine. So let us try to execute it. So let's write the query. Select course ID from section S, semester equal to fall and equal to 2009 and now we are writing the subquery. So select start from section T semester equal to spring and year equal to 2010 and one more condition. What that condition should be? We are going to find out whether a particular course from the outer subquery is taught in spring 2010. So we are matching here the course ID from outer query with the course ID of the relation inside this subquery. So inside this subquery section is renamed as T. So we are matching the course ID from the outer query S dot course ID with the course ID from the section table in the inner query. Okay, so let's execute this statement now, and what we are getting is CS101. So if you remember, this is the same output that we have seen by making use of intersect operation and in operation. Both were providing the same result, and this query is also providing the same result. Right? So what we have done here, we have made use of this exist clause. So if this particular query is giving us non-empty relation, then this exist clause will be evaluated as true and that particular course ID will be included in the result. If this inner subquery is evaluated as empty relation, then this exist clause will be evaluated as false and that particular course ID will not be included in final result. Got it? Yes, any doubts so far? Any doubt?
No, ma'am.
May I proceed?
Yes, ma'am.
Fine. Now, let us try to write one more query. Find all students who have taken all courses offered in the biology department. Find all students who have taken all courses offered in the biology department. So how do we write this query? See, this is really very interesting. We need to develop the logic to write such kinds of queries. So we should be able to split our tasks and whichever constructs those we know, try to use those constructs to get the final result. Right? So what we want is, we want to find out the students who have opted for all courses offered in the biology department. So first of all, we need to find out the courses those are offered by biology department, right? So what we need is, we need to find out. So I'm going to write here what we need to do. We need to find the courses offered by biology department. Right? Now, please tell me how you are going to write this query. Which table you are going to make use of and how you are going to write this query. Yes. Come on. Refer to our university schema. We want to find out the courses offered by biology department. Yes. Which table to be used?
Department name.
Table. Which table to be used? We want to find out course or courses offered by biology department. So where that information is being stored? In which table? Which course is offered by which department? This data is stored in which table? Yes. Refer to your schema. Where I am having course ID, course name, department name. These details.
Course table.
Course table, yes. So we need to make use of course table first to find out the courses offered by biology department, isn't it? So how do we write this query? Yes? How to write this query now? Yes. Make it fast. I'm not asking you any difficult question.
Select course ID from course where department name is equal to biology.
Very good. So select course ID from course where department name is equal to biology. So this statement will provide us the course IDs. Those are offered by biology department. Now, what we want to extract? We want to extract the students. So student data is available in student table. So we need to make use of that table, student table, right? Because we want to extract ID of the student and name of the student who have taken all the courses those are offered by this biology department. So we need to make use of this student table in our outer query. Okay, now this partial query is providing us the courses offered by biology department. Now, what we need to find next? Next, we need to find courses for every student. From this outer query now, we are going to check for each student. So we need to find out the courses opted by each student. Right? So we need to find out the courses. Those are opted by each student. Right? And this information, so we need to make use of student table. Then from this relation we'll be getting student IDs. So for each ID of that student, we want to find out which courses are taken by that student. So courses opted by each student need to be found out. So which table we need to make use of? Text. We are having one more table, text. In this text table, we are having the information like which student has opted for which course and section. Is that correct? Are you getting me?
Yes, ma'am.
So we need to make use of text table where we are having the information that which student has registered for which courses. We need to find out the courses offered by biology department, and we need to find out which courses are opted by each student. And now by making use of all this information, we need to write the query, final query. Correct? So we need to make use of three tables: student relation in the outer query, and in inner query we need to make use of two relations, course and text. Right? So see here how to write this query. See, in the outer query I am writing select distinct s.id comma s.name. So I want to extract ID of this student and name of the student who has taken all the courses offered in biology department. Okay, now so these two attributes I'll be extracting from student table, where now see here I'm using not exist clause, and will let you know why I'm using this not exist. Right? In not exist I'm writing the subquery, but see here in this subquery I'm using this except clause as well, or in Oracle I need to use this minus. Okay, so see here in this subquery, this first part of the subquery, select course ID from course where department name equal to biology. This will provide me the courses offered by biology department. Right? Now, this query, this part of the query is written for this text relation. So, what I am extracting out of this? I'll be extracting the courses. Those are opted by a student from outer query. So S is the relation that is being used in the outer query. So in the outer query, I am having all the students. So suppose in outer query, I am having the student ID, say 1, 2, 3. So for every student ID, I am going to compute this. So which are the courses? Those are taken by this student ID. So if student ID is 1, then which are the courses? Those are taken by this student with ID 1. That is what I am computing here. And this information is available in text. Okay. Now, why I am using here this minus clause or except? Set difference. See, suppose this this part of the inner query is giving me the courses offered by biology department. Suppose the first course that is offered by biology department is say 101 and say 203. So these two courses are offered by biology department. So let us assume that this is the result. This is the result of this query. These two courses are offered by biology department. Now, what this query will provide me? In outer query, I am having student ID 1, student ID 2 and 3. I am having only 3 students. Let us assume. So for every student, I am finding out which courses are opted by that student. So let us assume now that this student ID 1 has taken the courses, say for example, Bio 101 and CS 101. Let us assume, right? So for student ID 1, I am getting this result as the output of this query. So student ID 1 has taken Bio 101 and CS 101. The courses offered by biology department are these two. What I want to include this student ID in final output only if this student has opted for all the biology courses or all the courses offered by biology department. Now, I am having here minus. So, I am having now the set difference of this relation and this relation. So, I am having here minus. I am having minus. So, what I am trying to do is I am trying to find out the difference. So, if I try to find out the set difference operation of these two, what I will get? Bio 101, Bio 203 minus Bio 101, CS 101. So, I will be getting the course ID that is present in this relation but not present in this relation. Correct? Present in this relation but not present in this relation. So Bio 101 is present in this, so that will not be included. Bio 203 present in this relation but not present in this relation. So Bio 203 will be there in the result of this subquery, entire subquery. So in this result of the subquery, I am having this one tuple, Bio 203. Right? Now, I am making use of not exist. So not exist will be evaluated as true. Not exist will be evaluated as true if the result of this query is giving me empty set, empty relation. If it is non-empty, then it will be evaluated as false. Now, for this SID1, as this student has not opted for this particular course, Bio 203, meaning this student has not opted for all the courses offered by biology department. Right? And this is how this relation is actually not empty for SID equal to 1. So if this is not empty, then not exist will be evaluated as false. And this student ID 1 will not be included in my final result. Okay. Now, let us assume that this student ID 2 have opted for 3 courses. Or let us have here another table. So this student ID 2 has opted for 3 courses. And what are these 3 courses? Bio 101, CS 101 and Bio 203. Right? Now, once again, for this SID 2, we will be having now this set difference operation between this relation and this relation. So, what I will get in the output? Bio 101, whether it is present? Yes. So, the course ID that is present here but not present here. If this is the case, then I'll get that. So, Bio 101 and Bio 203 both are present here. Right? So, in this particular result, I'll be having empty relation for SID equal to 2. Why? Because this student ID 2 has opted for Bio 101 and Bio 203. And these are the courses offered by biology department. So student ID 2 has opted for all the courses offered in biology department. Right? So this relation will provide, or this query will provide me the empty relation for SID equal to 2. And if this is empty relation, then this not exist clause will be evaluated as true. And if it is evaluated as true, then this student ID 2 will be included in my result. Right? The same process will be carried out for every student. Right? And only those student IDs and names will be extracted who have taken all courses offered in the biology department. Are you getting me? Yes? Are you getting me?
Yes, ma'am.
Yes, ma'am.
See, these kinds of constructs are somewhat difficult to understand. But if we try to come up with the logic, if we think logically, if we try to split our task into the subtasks and we try to find out the appropriate constructs, those will be helpful for writing the solution for the given problem. Then it will become simple. So please have a practice and try to implement such kinds of queries. Try to build the logic. And this is really a good time to practice on, to come up with the logic. Right? Now, let us see how we can write this query practically. So let us try to write it. S dot ID comma S dot name from student abbreviate it or rename it as S, where not exists. In parenthesis, we are writing now the subquery. Course ID from course where name equal to biology minus select T dot course ID from text, rename it as T, where SID, that is the student ID from outer query, SID equal to T dot ID. So T dot ID is the student ID from text relation and S dot ID is the student ID from student relation. So this query will find out the courses taken by the respective student from the outer subquery. Right? And this query will provide us the courses those are offered by biology department. We are having set difference operation here, minus, right? So this will provide us the courses from the biology department. Those are not opted by the particular student. So if this particular subquery is evaluated or this subquery provides us the empty relation, this indicates that all the courses offered by biology department are opted by the respective student. If I am having some course here in the output of this subquery, so if this subquery relation is not empty, this means that few of the courses offered by biology department are not taken by that particular student. So not exist will be evaluated as true if subquery result is empty. It is evaluated as false if subquery result is non-empty. Okay. So let us try to execute. We are getting here no data found, meaning we do not have any student who has opted for all the courses those are offered by biology department. Right? So we are not having such entry in our database. And that is why we are getting here the output as no data found. Got it?
Yes, ma'am.
If you have any doubts, please let me know. Otherwise, I am giving you one homework. Have you understood this? Yes? Have you understood this?
Yes, ma'am.
Fine. So, let me proceed with one homework I am going to provide you. And actually one more clause that I am going to cover under this, that tests the absence of duplicate tuples. So I'll just give you the clause unique. So the unique construct actually tests whether a subquery has any duplicate tuples in its result. Unique clause is useful to test whether a subquery is having any duplicate tuples in its result. Okay, so if I want to write a query like find all courses that were offered at most once in 2009, then I may write the query like select t dot course id from course as t where unique, and then this is my subquery. So this subquery is actually providing me the courses, right? So this is providing me whether the course in the outer subquery is offered in this year 2009. Okay, and all those tuples it will provide. So this may have the duplicates. So this result may have the duplicate course IDs. If that course is being taught more than once in this particular year, right? Now, what this unique clause will do, this unique clause will find out whether this particular subquery is having a single entry, a unique entry. If it is having more than one entries, this means that this particular course is being taught more than once in this year, right? And what we want to find out the courses, those were offered at most once, so only once. So unique will be evaluated as true if in this subquery I am having a single tuple, a unique tuple. Otherwise, it will be evaluated as false, right? So this is a simple construct to test for absence of duplicate tuples. But let me tell you, this unique construct is not available in Oracle. It is available in other RDBMS, but this is not available in Oracle. Okay, so you may try this unique or not unique. I hope you must have understood actually the meaning of this construct. Okay, now I'm giving you one homework. So take down the statement. Find all courses. Find all courses that were offered. Find all courses that were offered at least once. At least once in 2009. Find all courses that were offered at least once in 2009. So try to write the query. Okay, so as I stated, in Oracle we are not having this unique clause. So write the query without using unique clause. Write the query without using this unique construct. Got it? So what you are supposed to do? Find all courses that were offered at least once in 2009. And you are supposed to write the query without using the unique clause. So this is the homework for you. Okay? Fine. So I hope you must have understood. Once again, I would appeal all of you to practice all those constructs. It is really very interesting to implement SQL queries practically, right? So try to do that. So let's conclude today's session. In the next session, we are going to focus upon few advanced constructs in SQL. We'll see how to create views, and also we'll focus upon the concept of derived relations. Okay, so let's stop today. Thank you.